Hi everyone, my name is Pawan. As part of SDET Essential series, I'm going to start a new topic which is Docker, and it is going to be multiple series. As part of this video, I'm going to give an introduction about Docker. Now let's see the agenda for this video. So as part of this video, I'm going to discuss about a few important topics which are required to understand what is exactly Docker is and how it is going to work. So what is virtualization? Then what is containerization or container management? Then what is Docker, Docker container, and Docker image and Docker hub? So let's understand these terminologies in Docker world. And then we'll discuss about Docker container lifecycle. And we'll also compare virtualization versus Docker. And finally, we'll see how Docker helps in automation. So this is the agenda for today. Now, so first of all, let us see what is exactly virtualization and containerization. So before understanding these two topics, virtualization and containerization, we need to understand few important things from the project. So suppose if you go or working on some projects, the developers will develop an application, right? And testers will test that application. So when you're developing or testing applications, there are a lot of things will be there. So for example, let's say developer, as a developer, they develop the software, right? So they develop the software. So we cannot directly ship this particular software to the customer, right? So before shipping the software or before delivering the software to the customer, we need to perform a lot of testings. So who is responsible for doing the testings on this particular software is testers. So testers will perform the testing on this particular software. Now, suppose the developer is provided the software or release the software to the testing team. So the tester will perform the testing on this particular software, perform the testing on the software. Now, so when the tester is doing the testing on this particular software, we need to test. As a tester, I need to verify whether the software is working on multiple platforms or not. So multiple platforms in the sense, it can be multiple browsers, or it can be multiple operating systems, or it can be multiple configurations, right? So as a tester, we need to verify all these things, but maybe as a developer, they may not verify all the configurations. But as a tester, before releasing the product to the customer, I need to verify all kinds of platforms, right? So this is a mandatory thing. So for that, what we need to do is I need to set up all the environments. First of all, let us say I have multiple combinations. Let's say I have Windows operating system, and on Windows operating system, I need to test my application by using Chrome browser. And again, every browser having multiple versions. And also I need to verify that on IE browser, or I need to also verify with the Firefox browser. And also I have some Java version in that particular operating system, right? So language requirement, operating system requirement, and browser requirement, along with this different browsers also will be there. So we need to configure the multiple platforms. So let's say I want to certify my project, or I want to certify my test cases on multiple operating systems or multiple browsers and multiple versions. So for that, what we need to do is we need to prepare a matrix where we need to cover all the combinations of testing, right? So for every combination, we need to set up an environment where we can execute our test cases, right? So to do this activity, normally what we will do is in the real-time projects, we will set up a VMs. So VMs in the sense virtual machines. So we will set up all the VMs. So for one kind of a combination of environment, we will set up VM. So for example, I have a Windows VM. So in the Windows VM, I will add all the software, or I'll install all the software which are required for certifying my test cases. Or I will set up another Linux VM. So where also I will set up all the required things which are required for test cases. I will install there, and then I will run my test cases. So to cover all the combinations of testing, we need to have multiple VMs, right? So this is the concept of virtualization. So virtualization is a kind of a technology where we will maintain the multiple VMs, which contains a different type of configurations, and which contains a different type of softwares, where we will execute all our test cases in those VMs, and finally we will certify them. Okay, so this is a concept. So in this particular concept, the problem here is we need to set up multiple VMs, right? So it is very, very costly, and there are some disadvantages are there. So basically this is a virtualization concept. So what exactly virtualization means? A virtualization means run multiple operating systems on single physical systems. So for example, I have a machine or I have a laptop or computer. On my computer, let's say this is my computer, and currently I have Windows operating system in my computer is running. Okay, so let's say I have Windows operating system, Windows 10. Now I can execute my test cases on this particular local system, but I want to certify my test cases on different operating systems. Here I can install a VMware, a kind of a software, and by which we can open the multiple operating systems. I need to set up multiple VM. Let's say this is VM1 or VM2 and VM3. So every VM is having their own configurations. So we need to execute our test cases on different VMs, and then finally we need to certify that. So what this is concept of virtualization. This is a concept, and every VM has its own operating system. And here we have a Windows, here we have a Linux, we have here a Mac, or every VM is having their own operating systems and their own configuration. So we can run our test cases on multiple virtual machines, right? So this is a concept of virtualization. So virtualization means run multiple operating systems on a single physical system. And in virtualization, every VM is independent. Let's say this particular picture, and if you just see here, I have a host OS. Let's say this is Windows, and there is a component called hypervisor. So this particular component will maintain all the guest. So because every VM is having their own operating system, so they are called as a guest operating system. And one VM can have Windows, or another VM can have Mac, or another VM can have Linux. So each VM having a different setup and different operating systems and the different configurations. So these VMs can be maintained in our physical machine. So whenever we want to work with that VM, we can just make that VM up, and we can log in into that VM, and we can work we can perform all the tasks. So whatever we plan. So this is how the virtualization works. And if you just notice few important points here is, on virtualization, every VM is independent. And to set up the VM, hypervisor is required. So this is one more important component which is required to maintain the setup and maintain the VMs. And every VM has different credentials. So it is just like a one of the instance of operating system. So even though we have a physical machine, you can maintain multiple VMs. So every VM is act as a different instance, and every VM is having their own operating system, their own softwares, even though those VMs are independent. So every VM has their own credentials. So for running an application, you need a VM. So if you want to run application, we can install on that particular VM, and we can run that application inside that particular VM. And if you set up multiple VMs for an application, then we need multiple isolation VMs. So for example, I want to test an application on multiple operating systems or multiple browsers. Then the same application should be installed or test on multiple operating systems. That means we need multiple VMs here. Okay, multiple VMs are required. And space is also wasted, and which is very costly. So VMs are very high cost. And even though we set up the complete VM, which contains operating system, libraries, binaries, along with application also we are installed, everything will be there in the VM itself. So even though we have everything, we may not use all the stuff 100%. There are a lot of memory will be wasted. Our application may not occupy that much of memory, right? But only for environment purpose, we are just designing the VM. We are setting up the VM. But our application may not need all the space which is there in the VM. So that is another disadvantage in virtualization. So this is a concept of virtualization, means the run multiple operating systems on single physical system. Here all the VMs are independent. Every VM has its own operating system, and we can install our application on multiple VMs, and we can test accordingly, and can finally we can certify our test cases on the particular application. So this is a concept of virtualization. Now, so what is the problem in the virtualization? So based on the problems, the containerization concept came into market. So the problem in this virtualization is basically the VMs are very costly, and we need to set up the complete VM along with operating system. Okay, and the moreover, every VM is independent. Okay, they cannot maintain in one shot, so every VM is independent, and they're having different credentials. And once we have a job is done, we don't require this particular VM, right? So these are main problems in the virtualization. So we will also discuss another problems in the virtualization while comparing with the virtualization and containerization. So first, let us discuss about containerization also. So we have seen the virtualization, the approach, how we have to maintain the VMs and how we are going to manage VMs in virtualization. Now come to the containerization. What is exactly containerization means? It is also kind of virtualization, but it's thin virtualization. We can say it is a thin virtualization. Here, containers means a VM. So we can containerization, we have only containers. In the virtualization, we have only VMs. Similarly, in the containerization concept, we have containers, and we can assume those containers as a VM. So containers act as a VMs. So container has only one application. It will take the required files from the host OS. Container has no OS. So this is very important point which we need to understand. So what is exactly containerization concept is, here we have a host OS and there is a container engine, and here basically this containerization is supported by Docker. So once we have installed Docker, it will internally support containerization. This is a container management tool. We can simply say Docker is a container management tool. So before understanding the Docker, we need this particular topic, or with this concept we need to understand what exactly containerization is. In the containerization, unlike virtualization, we don't have multiple VMs. Instead, we have multiple containers. So there is a lot of difference between VM and container. So what exactly container is? These containers also will be there in the physical machine. But the container means it can have only the libraries and binaries which are related to application. But it doesn't have any OS its own. Okay, it is just seems like a VM, but it is not exactly VM. So but VM contains an operating system and their own stuff, right? But here container doesn't have any operating system at their own, and it doesn't have any kernel or resources from its own, and all the resources, kernel and BIOS settings, operating system will be shared from the host OS itself. So container will share all the basic stuff from the host operating system by using container engine. But what exactly containers contains? Container is having only applications and what are all the dependencies we require for that particular application to run. So only those things will be there in the containers. So that's the reason containers are very lightweighted. It doesn't occupy a lot of memory, and we will save a lot of memory. So these are all different advantages of containers. So this concept we can achieve by using Docker, right? So the single OS will be there, and we can create any number of containers. Every container is having their own configuration again. So the first container is having some different operating system, another container having another operating system, and third container having another operating system, and different browsers. Okay, and every container is again independent. Here also, just like a VMs, every container is an independent, his own setup will be there, but all the containers which we are creating shared the common resources from existing host operating system. Common resources, that means operating system, BIOS settings, kernel, so all these things will be shared from host OS itself. So that means containers doesn't have their own operating systems. Okay, so this is called as a containerization. But how we can achieve this is through Docker. So once we have installed the Docker, we can create multiple containers, and every container having this own setup. And whenever we want this container, we can just make it up and do the job, and we can stop the container or we can delete the container. Okay, that is the advantage we have. So this is a concept of containerization. So containerization is a thin virtualization. Here containers means just like a VMs, not exactly VMs. VM and container, there is a lot of difference. And container has only one application. So container can have applications, nothing else. Applications and along with the dependencies. If you want to run application, we need some dependencies, right? So those dependencies only will be copied, bins as well as libraries and binaries, and it will take the required files from the host operating system. What are those required files? Means BIOS settings, operating system, kernel settings, okay, and memory space, all these things getting from the host OS itself. And container doesn't have OS at their own. Okay, that's the main important point, which is difference between VM and container. All right, So it does not have any OS, and it will perform very faster when you compare to the VM. And these containers are self-sustained. That means, suppose if you want to test my application on this particular container, we will install that application along with all the dependencies. Everything will be part of this container. And in future, if you want to share this container for some other, we can also share it in the form of images. So everything will be there here in the container itself. Everything it contains: application, installation, required dependencies, everything will be there, and browsers, required browsers, everything. So self-sustained. So whenever we want to test something, we can make this up. We can start a container, or if you want to shut down this, we can stop my container, or we can delete the container. So different operations we can perform. And it is a layered architecture. So first OS is there, on top of it container engine will run, and this container engine will maintain all the containers within the Docker. So this all comes under the Docker setup. Basically, this is the architecture of Docker. And all advantages of virtualization. In virtualization, whatever advantages we have, the same advantages we have. So what are the advantages here is, we can have multiple setups. Similarly, in the containers also, we have multiple setups, multiple configurations, right? So this is all about virtualization and containerization. So now let us compare virtualization and containerization. So if we just go to the virtualization, this particular one is virtualization. In virtualization, we have only one host server. On top of, we have host server, in the sense is a physical computer, and we have a operating system, and here hypervisor is a component which will maintain all the VMs. So here these are all the VM1, VM2 and VM3. Every VM is having their own virtual operating systems, and also binaries and libraries along with their applications. So here app and MySQL, these are all applications. So every VM is having their own virtual operating systems and binaries and libraries which are required to run applications, and along with the application installations. Everything will be maintained by multiple VMs. When you come to the containerization, we have a host server, that's a physical computer. Operating system also will be there. And here it will maintain a component called containerization engine. So this particular engine will maintain all the containers. So let's say if you see this container, the container doesn't have any operating system. Okay, those, let's say here OS1, OS2 means this is just a logical representation. It doesn't have any kind of operating system setup. But whatever operating system we have in the host server, the same operating system will be shared by the containers. Containers, applications, everything will run on operating system only. But that operating system will be shared from the host server, right? Physical machine. But in the case of virtual machine, that's not like that. It will not share. So every VM is having their own operating systems. But in case of containers, the base operating system, whatever we have, will be shared. All the resources like memory space, BIOS settings, kernel settings, everything, whatever is belongs to operating system, all the files will be shared across multiple containers. And what this containers contains is only the binaries and libraries which are required to run applications. Let's say this is a container 1, this is a container 2. So we can create multiple containers. So this is called as containerization concept. So virtualization and containerization concept. Now we will see exactly virtualization versus containerization. This is a basic comparison between virtualization and containerization. So in the virtualization, we have multiple VMs, every VM is independent. And containerization, there are multiple containers. Again, containers also independent, but containers having different settings and configurations, and even VMs also having different settings and configurations. But in virtualization, we have a multiple operating systems in each and every VM, whereas in the containerization, we have single operating system will be shared across multiple containers. And here VM containers contains operating system along with the binaries and libraries, plus applications which we are going to install and test. And in the containers, we have only binaries and libraries, because operating system will be shared from the host server, so that it will contain only binaries and libraries along with the application. So these are all basic differences. And we will also see more differences and compare virtualization, containerization. So later we will do that. And before that, so based on this one, we have understood what is exactly virtualization and containerization. Now we need to discuss what is exactly Docker, Docker container, and Docker image. So these are the terms which we need to understand before going to understand Docker. So what is Docker? Docker container, Docker image. We also have one more, Docker hub. So we need to understand these terminologies. So let us see what is exactly Docker is. A Docker is a containerization platform that packages your application and all its dependencies together in the form of a Docker container to ensure that your application works seamlessly in any environment. So definition is very lengthy, but I will simplify this. And simply when I say Docker, a Docker is a software or it is a tool by which we can set up containerization environment. So where we can create multiple containers, okay, and we can set up multiple configuration within the containers, and we can test our application inside the containers. So Docker is a containerization, or it is a content management tool. It's a basically containers. It will maintain multiple containers. So let me just give you the very basic stuff here. So what is exactly Docker is? So Docker is a tool, okay, or containerization software which will support containerization concept. So what exactly Docker will do is, suppose I have a Windows operating system. Let's say I have a Windows operating system. This is my host operating system in my physical computer. So once we have installed this Docker, so what are the facilities it will provide us is, once you have this Docker, we can create multiple containers. These are called Docker containers. Let me just make clear about these terms. It's very, very simple, guys. So this is my host operating system, which is a Windows. So once we have installed Docker software, by which we can create multiple containers. Let's say this is container 1, this is a container 2, this is a container 3. So there are 3 containers I can create. So these containers, in these containers, we can do setup configuration. And as I said before, these containers don't have any operating systems of their own. Okay, so the container is just like a VM. And by using Docker, we can create multiple containers. And what containers contains? The containers contains the binaries and libraries or dependencies. We can simply say dependencies which are required to run our application, and along with the application. So every container is having binaries and libraries along with the applications. So Docker is a software by which we can create multiple containers where we can run our applications on different environments or different configurations. That is the basic meaning of Docker. Now, Docker container, as I just told you, Docker container is a standardized unit which can be created on the fly to deploy a particular application or environment. So it could be Ubuntu, or it could be CentOS, or it could be Windows, or it could be Mac, anything. So Docker container is a kind of a unit in which we can do the configuration. So it will be created on the fly by using Docker, and the container can be either Mac OS, or it can be Mac, or it can be, as I said before, container doesn't have operating system their own, right? So if we just go to the previous slide, as I said before, container doesn't have any operating system their own. So whatever operating system we have in the physical machine, the same operating system will be shared. Okay, all the resources, operating system shared in the sense it doesn't have any operating system by default. Only the common resources will be shared. So in the container, we have only the binaries and libraries which are required to run application, plus applications it should be installed, but we don't have any operating system there. Okay, but we can create this container based upon the Mac or Linux or Windows, whatever, but it doesn't maintain any operating system their own, right? So we can just consider this as a VM, right? So now let us understand what exactly we have understood what exactly Docker is and Docker container is. A Docker is a software by which we can create multiple Docker containers. So what is Docker container means? Docker container is a unit or a component in which we can add all the dependencies. We can specify the dependencies and we can install application. We can add all the libraries, binaries, and everything which is related to application. So all these things will be maintained in the Docker container. It's just like a VM. Now the next one is a Docker image. So what is exactly Docker image? A Docker image is a file comprised of multiple layers used to execute code in a Docker container. So image is essentially built from the instructions for a complete and executable version of an application. So I will just simplify this definition. What exactly Docker image is? Simple. Suppose if I want to install my Windows operating system, I need to use either exe file or MSI file, right? Similarly, if we want to create a container using Docker, we need a Docker image. So by using this Docker image, we can create container, Docker container. So what the Docker image contains again, Docker image is having a lot of files, a lot of components and a lot of dependencies. All these things will be there in the Docker image. So once you have executed this Docker image, the container will be created. Okay, container will be created. So all these things are possible only through Docker installation. So Docker is a software which will just provide the facility to create a containers. But what is exactly container means? Container contains the configurations. We can install browsers, we can install applications, we can add all the dependencies required for application. They are all should be a part of Docker container. And Docker container can be created by using Docker image. So Docker image is just a file by which we can create Docker container, right? So we have understood what is exactly Docker, Docker container, Docker image. So simply guys, if you want to launch a virtual machine VM, we need a file, right? VM file. So similarly, if you want to launch my container, if you want to create a Docker container, we need an image. Image is an executable file. Simply we can say image is an executable file, right? Or it may be ISO file. So when you install Windows operating system, you have a exe file or MSI file or ISO file. We need some source to install that. Similarly, if you want to install my Docker container inside the Docker, we need a Docker image, right? Now let's move on to the next one. So Docker Hub. So there is another concept called Docker Hub. What is exactly Docker Hub is? It is a cloud-based repository in which Docker users and partners create, test, store, and distribute container images. Very, very important. So the Docker Hub is a basically cloud-based repository. It is just similar to GitHub repository. Okay, GitHub repository contains different projects, right? So we can just get those projects. We can pull those projects. We can push those projects in the GitHub repository. So there, the centralized version control system will be there. All the projects we can have in the GitHub repository remotely. Similarly, here Docker Hub is also a cloud-based repository in which all the Docker images will be maintained by the Docker users. Right? As a developer, for example, I created a container by using an image, and those images can be get it from the Docker Hub. Suppose if you just go back to this content, go back to this concept. I have a operating system. I have a Windows operating system, for example. I have a Windows operating system. So I want to set up my Docker in my Windows operating system. So for that, we need to have a multiple containers. Let's say this is one container, second container, and third container on different OSs and different configurations. So let's say container 1, container 2, container 3. So these containers can create by using images, right? Docker images. And all these things are possible by using Docker software. So once we have installed Docker, we will get all the commands. We use certain commands to do all these operations. So if you want to create a containers, we need image. What is image means? It is a kind of executable file. And by using this image, we can create a multiple containers, or every container is having different image. Where exactly we will get these images? So all these Docker images will be there in the Docker Hub. So Docker Hub is a central repository, cloud-based repository, where all the Docker related images will be maintained. And we can get this image, one of this image based upon our configuration. We can get the image from the Docker Hub and install that image on the environment. Then you will get the container. And later you can copy all application dependencies inside this container. And then we can perform the testing. So what exactly Docker Hub is? All the Docker images will be stored inside the Docker Hub. Okay, there's a central repository. So not only for storing, suppose tomorrow I have created my container, I want to share this to somebody else. The same configuration I want to share with somebody else. I cannot give this container directly. I have to make an image out of it. I can make an image out of it, and then I can keep that into Docker Hub. Again, from there, the other guy can get the same image. So this is how we need to. So image to container and container to image, we can do that. So if you want to create a containers, we must have images. And once we have done work in the image, or once we have done everything in the container, our work is done. And suppose if you want to share the same configuration, same environment to somebody else, we can again make image out of it, and that image also we can push it into same central hub. So this is called as Docker Hub. So get the image from Docker Hub, work on this, get the image and install containers based on that image. Then work is done, and you can finally upload the image to the same Docker Hub. Okay, so this is the exact environment. So with this, we have understood what is exactly Docker is, Docker container is, Docker image, and Docker Hub. So these are the 4 important terms which we need to understand clearly when you work with the Docker. So Docker is a containerization software platform, and by which we can create multiple Docker containers. If you want to create a Docker containers, we need Docker image, and those images we will get it from the Docker Hub. Simple, right? So this is a concept of Docker. Now we'll move on Docker container lifecycle. So what exactly container works? So as I said just now, we can get the image, right? So we can get the Docker images from the Docker, and we can do push and pull request. So all the images will be there in the Docker Hub. We'll do pull action and get the Docker image, and using Docker engine, internally it will use Docker engine to pull the image from the Docker Hub. And once you pull the image, we will get the Docker images, right? So these Docker images will be maintained in the Docker Hub, and Docker will pull those images. And once you get this image, we will create a containers. And once you create your containers, and we can do that container run, we can stop that container. And if you don't require that container, once your job is done, we can delete that container, right? We can we can run the container whenever you require. We can stop the container temporarily, or if you don't even require your container, you can just delete the container. So these are the different operations we can perform on the containers. But if you want to share that to somebody else, you can make it as an image, and you can share that image to somebody else, or we can again push that same image to the Docker Hub. So this is exactly Docker container lifecycle, right? So now let's compare virtualization versus Docker. As I said, Docker support containerization. So virtualization concept is pretty old. So there we need to maintain multiple VMs, and right. So here we will compare exactly advantages and disadvantages of virtualization and containerization. Here Docker, in the sense, Docker is a tools which will support containerization, right? So the first point is virtualization, we use isolation of OS, but here in the Docker, we have isolation of container. What is the difference between isolation of OS and isolation of container? The basic difference between these two is, under virtualization, we have multiple VMs. Every VM is having their separate operating system. That is isolation of operating system. But in the Docker, we don't have operating system in the container, but containers are isolated. So containers are different, but in the containers, we don't have any operating systems. But in the virtualization, VMs are different. Every VM, there is a different operating system will be there. So that's a fun difference. And in virtualization, we have a lot of space will be wasted, because in the virtualization, to set up the VM, we need operating system, we need dependency, we need some hard drive space, right? But for one application or two applications, we need to do a lot of things, and it is very difficult to maintain, and space will be wasted a lot. And in the Docker, space is not wasted, because in the Docker containers, we have only applications and related containers that will not occupy much space. But if you still have the operating system, then it will occupy a lot of space. Operating system and dependencies, if you have all the things set up from the OS, and that will be again huge, and it will be space will be wasted. But in case of Docker, space will not be wasted, because Docker container contains only application related dependencies. Now in the virtualization, every files is installed. In virtualization, we have a VMs. In every VM, we need to have all files, including operating system. But in case of Docker, containers required only binary and library files. So only binary and library files will be installed, and remaining files shared from operating system, host operating system, because the container doesn't have their own operating system. So remaining files means system files, kernel, or other resources will be shared from the host operating system. But in the virtualization, every VM has their own operating system, so there is no necessity to sharing anything from the host OS. Now, if you want to start my virtual VM, it takes some time to boot, because just like a normal booting, even VM also will take some time to boot. But in the Docker, it will happen in very less time. So booting is it takes very less time. That's it for Docker. And take time to restart a VM, but in case of Docker, it takes very less time to restart your container. And if you don't want container, you can stop the container, we can restart it, we can delete it. But same operations if you want to do in case of VMs, we need to shut down the VM, we need to restart the VM, we can stop the VM, we can also do operations, but it takes a lot of time. So these are all advantages and disadvantages are there in virtualization and containerization. So here containerization in the sense Docker is a tool which will support containerization, right? So these are the differences. So with this, we have understood exactly what Docker is, what it has, what is container, what container is, what Docker image, Docker hub. Now, finally, we will see exactly where the Docker helps in automation. So where exactly how the Docker helps in automation. Now, let us see this particular scenario. I have set a number of test cases. I want to certify those test cases on multiple operating systems, on multiple browsers. Okay, that's my requirement. So to achieve this particular requirement, we have a concept in Selenium, is called as a grid, right? So by using Selenium grid, we can set up distributed environment where we can execute the test cases across multiple operating systems and multiple browsers. So there we have a grid hub and a node. So this particular concept will be followed. So in this particular Selenium grid concept, so here the problem is when I run my test cases from my local system, the grid will maintain all other VMs. So here also these setups will be there in the VM. So suppose in the one VM I have Mac OS, another VM I have Red Hat, another VM I have a Windows. And every VM is also having multiple browsers and multiple versions again, right? So once you run my test case sequentially or parallelly, so grid will maintain all the VMs internally, all the IPs and all the configuration will be maintained by the grid hub, right? So once you executed our test cases by using grid component on multiple operating system and multiple versions, it will be very complex. We will run into a lot of issues. So for example, as per our requirement, one system is having Java. Suppose my test cases are running in Java 6 or 7 or 8 in my local system. Maybe in the remote machine, I should have another version of Java. My test cases may not run on this particular Java. Or in local system, I verified my test cases on Chrome browser 64. And suppose in remote machines, I have a Chrome browser 64 or 65 or 66, some other version, right? So we have a multiple browsers and multiple versions. If you want to maintain all these resources, it is very difficult task because these environments will be virtual machines basically, right? So grid should maintain all the virtual machine information, including IP address. And every virtual machine should have browser installation and Java installation and libraries, binaries and everything. So this is a little complex process and we will run into a lot of issues. Selenium versions will be different, TestNG versions will be different, Chrome driver versions may be different, right? And sometimes we'll get permission issues, firewall issues, a lot of things are involved here. So to overcome this particular problem, if I use a Docker along with the Selenium grid, our process will be very easy. So in the Docker with Selenium grid, how we can overcome this problem is, instead of creating these VMs, so actual test script is there in my local system. And even Selenium grid is also running on my local system. Our Selenium hub is maintaining the remote nodes, right? So these are the grid nodes. So these nodes will be maintained by this our grid hub, which is there in my local system. But once you have installed the Docker, what we can do is we can just have all the grid setup in one container. So let us say this is a container, and here we have a Docker, and this is my script, and with all the dependencies. Let's say we have Java dependencies, we have Apache dependencies, we have and TestNG dependencies. A lot of dependencies are there. So along with the dependencies and the scripts, we will set up grid environment within the container, right? So this grid will again we can also set up multiple browsers or multiple versions. So this container, we have all the test cases and grid setup along with the browsers. So this is independent now. So this is one container. Similarly, suppose I have one more container, there also we have a grid setup, test cases, and multiple browsers. So suppose tomorrow, if you want to share this environment, we can just make image out of this particular container, and you can share that image to somebody else, and they will also get the complete every configuration. They don't miss any single component. Okay, so that's how it will be very, very useful. So instead of virtual VMs here, we can create the containers. Every container contains a complete configuration. But in case of without Docker, and all the dependency scripts will be there in some other machine, and grid hub is running on my local system, and remote machines or VMs. So to maintain this setup is very, very complex. So to simplify this, to make easy of this, we have a Docker concept here. We can introduce a Docker concept in our automation. So just we have to create multiple containers with the different configurations and push every configuration into that particular container and do the work. And once work is done, we can stop the or we can stop the container, or we can remove the container. Or if you want to share that environment to somebody else, we can create image out of it and we can share that with somebody else. And in future, if you need the same configuration, again, we can start the same container and we can run our tests. So this will be created on the fly. Okay, and as soon as our job is running, as soon as we are working on this container, still we can make it up and still running. Once our job is done, we can close this one, or we can even delete this container, right? So this is how we can make our complex thing into easier by creating the containers in Docker, right? So this is how we need to use Docker in automation, right? So in the coming sessions or coming videos, I'm going to show you how we can execute our automation test cases in Docker environment, or how to install it, how we can create a containers, and there are a lot of things are there. So I'm going to discuss all these things in the next videos. All right. So that's all for this video, guys. So thanks for watching.